We interact with mechanisms every day. From the moment we wake up to the time we go to bed, mechanisms are a part of our daily routines. They make our lives easier. Simple tasks like opening a can or adjusting a bicycle chain are made possible by these ingenious devices. A mechanism is a device. It uses moving parts. These parts work together. Each part has a specific role, and together they perform a function. They achieve a specific goal. Mechanisms are everywhere. In our kitchens, we use blenders and mixers. In our laundry rooms, washing machines and dryers. They are in our homes, cars and toys. Understanding mechanisms is important. It helps us appreciate the complexity and ingenuity behind everyday objects. It helps us solve problems. Engineers and mechanics use their knowledge of mechanisms to fix and improve machines. It helps us design new things. Designers and inventors rely on mechanisms to create innovative products that improve our lives. Think of a simple pair of scissors. It's a mechanism. It uses two levers. These levers are connected at a pivot point. These levers pivot at a fulcrum. The design allows us to apply force efficiently to cut through materials. Scissors allow us to cut paper. They are used in various tasks, from crafting to professional work. This is a simple task, but it shows the power of mechanisms. Even the simplest tools can have a significant impact on our daily lives. Mechanisms are the backbone of modern engineering. They are the hidden heroes that make our world function smoothly. From the smallest gears in a watch to the complex engines in our cars, mechanisms are all around us, making life easier and more efficient. A lever is a simple machine. It is a rigid bar. The bar pivots on a fixed point. This point is called the fulcrum. Levers can amplify force. This makes it easier to move heavy objects. Think of a seesaw. It's a lever. The fulcrum is in the middle. When you push down on one end, the other end goes up. The longer the lever arm, the easier it is to lift. Levers are used in many applications. They are in crowbars, hammers, and even our arms. There are three classes of levers. Each class has a different arrangement. This is the arrangement of the fulcrum, load, and effort. Class 1 levers. The fulcrum is between the load and the effort. Examples: seesaws, scissors, pliers. Class 2 levers. The load is between the fulcrum and the effort. Examples: wheelbarrows, bottle openers. Class 3 levers. The effort is between the fulcrum and the load. Examples: tweezers, fishing rods, our arms. Understanding the different classes of levers is important. It helps us choose the right lever for the job. A pulley is a simple machine. It helps us lift heavy objects. It consists of a wheel. The wheel has a groove. A rope or cable runs in the groove. Pulleys can change the direction of force. They can also reduce the effort required to lift an object. Imagine lifting a heavy bucket. You could use a pulley. Attach the pulley to a beam. Thread the rope through the pulley. Tie one end to the bucket. Now you can pull down on the rope. This is easier than lifting the bucket directly. Section 5. Gears, changing speed and direction. Gears are toothed wheels. They work together to transmit power. Gears can change the speed, torque, and direction of motion. When two gears mesh, one gear rotates. This causes the other gear to rotate in the opposite direction. The size of the gears determines the gear ratio. This affects the output, speed, and torque. Gears are essential components in many machines. This includes cars, bicycles, and clocks. Section 6. Types of gears, a cog for every job. Gears are fundamental components in many mechanical systems, each designed to perform a specific function. There are many types of gears, each with unique characteristics and applications. Understanding these differences is crucial for selecting the right gear for the job. Each type has a specific purpose, tailored to meet the demands of various mechanical tasks. The design and structure of a gear determine its efficiency and suitability for particular applications. Some common types of gears include spur gears, helical gears, bevel gears, and worm gears. Each of these gears has distinct features that make them ideal for certain functions. Spur gears. The most common type of gear. They have straight teeth that are parallel to the gear's axis. This simple design makes them easy to manufacture and highly efficient for transmitting power. They are used to transmit power between parallel shafts. Spur gears are often found in applications where high speed and low torque are required, such as in clocks, washing machines, and conveyor systems. Helical gears, similar to spur gears but with angled teeth. The teeth are cut at an angle to the face of the gear, which allows for more gradual engagement of the teeth. This allows for smoother and quieter operation compared to spur gear. Helical gears are used in applications that require high speed and high torque, such as in automotive transmissions and industrial machinery. Bevel gears, used to transmit power between shafts at different angles. They have conically shaped teeth and are typically used in differential drives, which allow the wheels of a vehicle to rotate at different speeds. Worm gears, used for large speed reductions and high torque applications. They consist of a worm, which is a screw-like gear, and a worm wheel. This setup allows for significant reduction in speed and increase in torque. Different gear types are used in different applications depending on the specific requirements of the machine. The choice of gear affects the efficiency, noise level, and durability of the machinery. The choice depends on the specific requirements of the machine. Factors such as load capacity, speed, and the direction of force all play a role in determining the most suitable gear type. By understanding the unique properties of each gear, engineers can design more efficient and reliable machines. Section 7. Cams and followers controlling motion. A cam is a rotating or oscillating component. It has a curved profile. A follower is a component that rides on the cam profile. As the cam rotates, the follower moves up and down or back and forth. The shape of the cam profile determines the follower's motion. Cams and followers are used in many machines. This includes engines, pumps, and printing presses. They are used to control the timing and motion of other components. Section 8. Linkages connecting the dots. A linkage is a system of rigid bodies. They are connected by joints. These joints allow for relative motion. Linkages are used to transmit motion and force. They can also be used to guide the movement of other components. A common example of a linkage is the 4-bar linkage. It is used in many applications. This includes windshield wipers, bicycles, and even the human knee. Section 9. Mechanisms in action, real-world examples. In this section, we will explore how mechanisms are integrated into various devices and systems that we encounter in our everyday lives. From the vehicles we drive to the bicycles we ride, and even the cranes that build our cities, mechanisms play a crucial role in making these machines function efficiently. Mechanisms are everywhere in our daily lives. They are the hidden forces that make our modern conveniences possible. Without these intricate systems, many of the tools and devices we rely on would not be able to perform their essential functions. Here are a few examples. Let's delve into some specific instances where mechanisms are at work, making our lives easier and more efficient. Cars. Cars use a wide variety of mechanisms. From the moment you turn the key in the ignition, a series of complex mechanical processes begin. The engine, which is the heart of the car, relies on numerous mechanisms to convert fuel into motion. This includes gears, cams, and linkages. Gears are used to transfer power from the engine to the wheels, while cams and linkages help control the timing and movement of various engine components. These mechanisms transmit power from the engine to the wheels. The transmission system, which includes a series of gears, ensures that the right amount of power is delivered to the wheels, allowing the car to move at different speeds. They also control the steering, braking, and other functions. The steering system uses linkages and gears to allow the driver to control the direction of the car, while the braking system uses hydraulic mechanisms to ensure the car can stop safely. Bicycles. Bicycles use gears to change the speed and torque of the pedals. When a cyclist shifts gears, they are engaging different size gears to make pedaling easier or harder, depending on the terrain. They also use linkages in the brakes and derailleurs. The brake system uses cables and levers to apply force to the brake pads, slowing down the bike. Derailleurs, on the other hand, move the chain between different gears. Cranes. Cranes use a combination of pulleys, gears, and levers. These mechanisms work together to lift and move heavy loads with precision and control. This allows them to lift and move heavy objects. The pulleys reduce the amount of force needed to lift heavy loads, while the gears and levers provide the necessary control to position the load accurately. These examples show the importance of mechanisms in our world. They are the building blocks of modern technology. enabling us to perform tasks that would otherwise be impossible. Understanding how these mechanisms work can give us a greater appreciation for the engineering marvels that surround us every day. Section 10. Conclusion: the importance of understanding mechanisms. Mechanisms are fundamental to engineering and everyday life. They help us solve problems. They allow us to create complex machines. Understanding the different types of mechanisms is essential. It helps us design, analyze, and improve the world around us. By learning about levers, pulleys, gears, cams, and linkages, we gain a deeper appreciation for the ingenuity of engineering and the elegance of mechanical solutions.